The ice cap of Greenland, north of the Arctic Circle. This white desert becomes an open laboratory for scientists who are making measurements of the ice and snow cover. They're taking part in the CryoSat validation campaign to check the data provided by the European Space Agency's Earth Explorer satellite.
The satellite is designed to get very accurate estimates, but the snow and ice is not a perfect reflector. It's not like a mirror. So the signals penetrate and change depending where you are, depending on the snowpack conditions, depending on the density of the snow, depending on the climatology conditions above. So we go to different sites to check the snow structure and trying to understand what is that the satellite is observing.
On the ice cap, the conditions are quite tough for the scientists, who must spend several days with only a small tent to protect them.
Every day we have to check in for weather, we have to check in for our gear, we have to check in for our food. Everything freezes. Elevation, you can feel it in your lungs. But other than that, it's very nice. It's a beautiful place.
In the Greenlandic sky, a small plane is passing. It's equipped with a radar and a laser. Indeed, the same instruments that are traveling much higher aboard the satellite circling the poles at an altitude of 700 kilometers to measure the ice thickness. Plane and satellite measurements are both made in connection with the work of scientists based on the ice cap.
We have to be underneath satellites tracks, and we also have to line up the system with the people doing groundwork and reflectors, so we have a navigation system for the pilots. One of the biggest tasks is to hit some corner reflectors that put on the ice, both sea ice and inland ice, and that's for the radar signal, so they have an exact point where it turns, so you can see where you have a reference for the surface, because you don't really know how far the radar penetrates down into the top layer of the ice.
As with any Earth observation mission, it's important to validate the readings acquired from space. This involves comparing the satellite data with independent and verifiable measurements. Therefore, the ground and airborne campaigns are the only way to ensure that CryoSat provides from space the accurate data expected. The ESA satellite is designed to detect changes as little as 1 centimeter per year.
Without these ground campaigns, we would not be sure of achieving the scientific objectives. We must ensure that the products are accurate, and to do that, we must compare with an independent source of information, and this is what the combination of ground measurements and airborne measurements is producing.
On this model, data gathered from several satellites already shows that the ice is melting. Now this information will be complemented by CryoSat, which will offer the most accurate data so far on the ice thickness. This will soon allow the provision of a global ice map for a better understanding of how the volume of ice is changing and how ice and climate are linked.